This conference will now be recorded.
It is a peculiar experience, as I was just about to say. So it's odd. It's an odd experience giving a presentation like this because you don't get feedback from the audience. But as Lynn has said, I'm perfectly happy to take questions at the end of it, and hopefully we can have a little bit of a debate. Lovely to see so many of you here. And some friends and colleagues from past and present even are here with us now. So let me introduce myself. Those of you who don't know me, Peter Dearman. I was BR trained through and through, cut me in half. It still says BR through the middle like a stick of rock. And I am fundamentally an electrification engineer. That's my core sort of expertise, competence, if you like. But I've done lots of other things as well across my working life. I want to, well, for now, I'm retired, but I'm still working as a consultant supporting Network Rail in a number of electrification activities. So can we go to the first slide, please, Lynn? Thank you. So what am I aiming to do tonight, or this afternoon rather, want to give you a brief history of the development of electrification. That's important. Churchill it was, I think, who said that if you understand history, you stand a fighting chance of understanding the here and now. And that's true of this subject. I want to place the electrification system, electrification of the railway, in the context of the 21st century, the here and now, in other words. And I want to give you a view on what I think the challenges are that the industry faces, and this sector of the industry, electrification particularly, and most important, I really hope I'm not going to bore you to death while I'm doing that. So if we go to the next slide, please. Thank you. So why do we need electrification? I want to just share these things with you, these thoughts through with you, so that you can hold these in your head and try and understand against the background of these issues why I'm saying what I'm saying. Electrification, electric trains are cheaper. The trains are cheaper in themselves because they contain less technology. Old trains contain a devil of a lot of technology these days, but electric trains don't have engines. They're quieter. They don't make a noise. If you really want to compare a modern electric train and its modern diesel alternative, go and stand next to a Class 68 as it pulls out the platform. I defy you to think that that's reasonable to have that noise at a platform in a station, never mind about rumbling along the railway. Electric trains are cleaner. There are no exhaust fumes from electric trains. They don't have anything to pass exhaust from. Carbon isn't generated at the train. Yes, the generation behind the electrification system has to be carbon free, but the train itself puts out no carbon. And they're lighter. So all you guys from the track side of the railway will appreciate that less axle loads leaves the rail, ballast and sleepers to last longer. They are more powerful also. An electric train of, let's say, 4,000 horsepower compared to a 4,000 horsepower diesel train is to all intents and purposes twice as powerful. The diesel train can never generate more than 4,000 horsepower. The electric train, by the nature of electric traction, can provide 200% overload for a period of time. It can be an 8,000 horsepower train for a short period, short being up to 2 hours, incidentally. And electric trains are operationally more flexible. Could we go to the next slide, please? So let's talk about climate change. Unless you're of a mind that climate change is still something you doubt happens, it's clear that humanity urgently needs to respond to changes which will move away from fossil fuels. That's important. It's true that hydrogen as a technology is developing, but my own personal belief is that hydrogen will always suffer from the hugely inefficient cycle, energy efficiency cycle, with its production and use. Batteries, they might be good, they are good for some things, but battery technology has got a long way to go before it can support some of the more outlandish things that people are planning to do. And I would remind everyone that the batteries themselves are made of rare earth metals. That word rare is quite important in this context. I think everybody who has ever looked at the various energy options for rail has concluded that only full electrification works for mainline, high-speed, heavy trains. So, if all that is true, why are all railways not already electric? And that's where we need to go away and think about history for a bit. Can we go over to the next slide, please? This bloke, I think I admire what this bloke did. I think I probably would have hated working with him or for him, even, as I probably would have been, because he was a dominant figure in his time. But we owe a lot to him. He did a lot for the railway. But even as he started to get going in the rail industry, he understood that carting coal, boiler, water, and engine and motion around with the train to bring the motive power was a bad idea. He only had winches and chains and cables, and then he hit upon the vacuum system, the atmospheric propulsion, as it was called. He near on bankrupted his client by trying to do it in South Devon Railway. And he could never make it work because the materials technology wasn't up to it, and it wasn't really a very sensible system anyway. But he was right fundamentally. Don't cart the prime mover about with you. Next slide, please. Too late for Brunel. He died 17 years before Siemens unveiled this thing, and the first real practical demonstration of an electric locomotive in 1879. That was picked up by Westinghouse in America and further developed. And by the latter years of the 19th century, electric traction had become a viable technology. Can we go to the next page, please? So to give a bit of local flavour to this, I thought I'd just say a few words about the important scheme that R.M. Dealey, the electrical engineer in the Midland Railway, pursued in the early 1900s. Announced in 1906 and astonishingly finished in 1908, that electrified the Morecambe Heysham Lancaster Railway. Electric services on that ceased in 1951, but it played a seminal part in helping to develop the electrification scheme that eventually the West Coast Main Line was based upon. Next slide, please. That's for those who aren't familiar, and I'm sure you all are, that's where the line is, and that's the old railway clearinghouse map that shows the Midlands lines and the London North Western lines around the area. Next slide, please. This picture, I believe, is the Midland powerhouse that was at Heysham. It was already there for cranes and so on and so forth in the dock area, but it was expanded for the electrification of the line. It represented the state of the art at the time, but it reflects the fact that this was all done, and incredibly, this was all done long before the country had a national grid. And it was an extraordinarily inspired bit of a decision by the Midland to build an AC electrified line. Next slide, please. That's the rolling stock for the line. I find it very interesting looking at these two pictures that the top one, the Westinghouse power car, is obviously sitting somewhere in the territory where the line is on the LNW route, because it has steel structures throughout. The one on the bottom is further onto the Midland somewhere because it's actually held up by wooden poles. Those were the days. Can we go to the next slide, please? And that is Morecambe Station. My goodness, weren't the railways bigger back then? What's interesting on there is those multi-track portals over the platforms. It was clearly a big operation running trains back in those days. Next slide, please. Just to make sure that the Wars of the Roses carries on, let's not fail to extol the virtues of stuff that happened on the other side of the Pennines. The North Eastern Railway, under the leadership of two people who everything I read about them tells me that they're worth some admiration from people like me in the electrification side, was Sir Vincent Raven, the CME of the North Eastern, and Charles Mertz, the co-founder of Mertz McClellan, the electrical engineering consultancy. The four pictures here, top left, is the Tyne Electrics, which as a third rail scheme predate the work on the southwestern railway, which became the southern region, which is where we think of conductor rail there in Liverpool as being the centres. Northeastern beat the lot. Top right is the Harton Colliery, where shunting moves in the colliery were managed by that very impressive little shunting engine on that picture. Bottom left is Tyne Docks, where similar shunting operations were done. And the one that's my real favourite is that extraordinary locomotive, bottom right, which in that picture is sitting at Simpasture Junction on the Shildon Newport Electric Railway. That is locomotive number 13, built specifically as the proving pre-production prototype for ECML electrification. That's about 1922-23, I imagine. And it's extraordinary to think that electrification of ECML was an ambition even back then. So could we go on, please? I've kind of given you a smattering of schemes, just A, for the sake of putting some pictures up in this presentation, and B, because it illustrates something. An awful lot of electrification work had gone on through the early part of the 20th century, and I've listed there a lot of other schemes and projects and ongoing electrifications, which I think are significant in the evolution of the technology. Next slide, please. So I've kind of brought you up to 1939, and of course the Second World War was a huge event and stopped a lot of things happening that would have carried on in rather different ways. But the point is, up to this point in this story, the 19th century saw the emergence of electric traction as a possibility, and developments went on therefrom. During those early years, up to 39, schemes had been progressed, experiments had gone on. It had become clear that by about 1927, there needed to be some consistency in the approach if a concept that we recognise from Europe now, interoperability, was going to be the case. And so a report was commissioned by the Board of Trade, and the Weir report standardised 750 volt conductor rail and 1500 volt overhead systems for the future. Next slide, please. So standardisation carried on. And after World War II, BR came into existence with the scheme on the Great Eastern Main Line having started in 1938 and stood still all through the war. That went on to be finished. That also projected the same technology into use on the Manchester, Sheffield and Wath Railway, which progressed up until the 50s. In its early years, BR took those schemes forward, but recognised that different systems of electrification in Europe had emerged. And those systems, they seemed to offer some economic advantage. And so after some pretty extensive soul searching and some research into what SNCF were doing in France, it became clear that it was more beneficial to pursue a 25 kV alternative than 1500 volts. And it was that system between UIC conferences in 56 and 62 that BR eventually adopted. And so now we can go onward with those sort of post-war and up to now years. If we could go to the next slide, please. Thank you. The British Transport Commission in 1955 actually published a plan. It made clear that steam and diesel were to be progressed, but as interim measures towards an electric future. Originally in 55, that was a 1500 volt DC standard, and there was a plan to electrify much of the network by about 1990. And there were plans for how many locos needed to be built, all that stuff. But austerity slowly killed that electrification plan. And of course, we ended up with dieselisation, horrible word, taking the fore. Next slide, please. The modernisation plan, though, was in part successful because the shift to 25 kV tipped the scales. We got the original Euston, Manchester, Liverpool electrification approved and funded, and it proceeded. But unfortunately, by about 1967, the costs and the programme delays had started to become a problem. And the then Minister of Transport, one Ernest Marples, who by coincidence was the chairman of Marples Ridgeway, the main motorway builders at the time in the UK, decided that rail investment wasn't the best thing to do. And the scheme was halted and came in for some immense criticism because of the cost and inefficiency of its delivery. Eventually, BR addressed the costs, and the WCML, as you know, up to Glasgow was completed. Could we go to the next slide, please? I want to pause there and just pause the narrative and just talk about what BR did between 1967 and 71. It was extraordinary. The changes that were made ranged across project management and project delivery. Sorry about this. This is yeah, go away. The changes were quite extraordinary. Project management was changed. The whole mantra of how electrification was tackled, the programming, every aspect of the job was given a whole new dusting down and a change. In the engineering content, the overhead line was re-engineered into a new, lighter, cheaper, simpler form. And as the scheme then came back to life and progressed north of Weaver Junction, a lot of that work was consolidated, and those measures brought us to the most effective and successful and cheapest forms of electrification that we've ever managed to do in the UK. Next slide, please. British Rail then was mature by this stage, and in 1977, BR published the electrification plan, which was known as Option 5. Option 1, 2, 3, and 4 were sub-options. Option 5 was the whole-scale electrification, and that was selected. It was supported by government, it was supported by industry, and the supply chain was mobilised to take the steps to produce engineered components, parts, and equipment, which would enable an 11% return on the investment, which is an extraordinary return. Unfortunately, in May '79, realpolitik came to the fore. Margaret Thatcher was elected, and the wind of change brought a different approach. The HST won out over the APT, and that was the end of the whole of Option 5. But, next slide, please. We did manage to do a bit. The big bit is ECML, but we mustn't ignore the schemes in Anglia and Scotland, which were completed during this phase. But ECML is clearly, to me, the biggest success in this whole timeline, this story. But when it was completed, privatisation was already heaving into view. With privatisation came a different set of priorities for the new railway. Signalling first grabbed all the attention, and then track grabbed the attention a bit after that. And so much so that in rail track days, electrification fell completely from the agenda. So let's go to the next slide. But we come around to 2010, and Network Rail announces a new invigoration of electrification. We get the Network Electrification Programme defined, a new rolling programme to electrify the network. This had full and enthusiastic backing from the DfT, but in CP5, the costs and the programme overruns began to alienate the Minister of Transport. This has happened before, isn't it? And it's shelved again and halted. So let's go on. Thank you. Part of the scheme was, however, completed. There was a lot of work up in the northwest. But I guess I wanted to say a few words about Great Western particularly. It was a much overspent and delayed scheme. It was curtailed. Nothing west of Cardiff was electrified. The line round through Bath still remains diesel only today. Oxford didn't join the electric network. However, for all the sins of the project, what has been built is undoubtedly a railway that is something to be proud of, I think, by the people who built it. So let's go to the next slide. So what point am I trying to make by all this? Well, what has that history shown us? It tells us that right from the start, electrification has been an obvious and superior solution to railway traction. It tells us, actually, if you look at the experience of each railway that has progressively become electric over those years, that every scheme tackled has been transformational to that line of route and a success once in operation. Passengers, the railway, businesses and communities, as I say on there, they've all benefited from those changes. And as an example, if you went to GW now, which was undoubtedly one of the most painful experiences in implementation that you can think of, both for the industry and for the people travelling on that railway at times, But I bet you that if you could get a sample, a focus group out of passengers who travel on that railway and offer to return the HSTs to them, there's not one who would say, yes, that's a good idea. Next slide, please. And if that's true of Great Western, it's true of all these across time. Top left of that picture is the London Brighton and South Coast Railway, that archetypally southern region route that's conductor rail now. That was electrified, first of all, as an AC overhead electrified railway. That picture, I think, is at Coulsdon somewhere. The next one across is, I believe, in Italy. Next one is Poland. The next one, Denmark. On the bottom line, that's Egypt and ECML, and then Central France. Every one of those railways, and hundreds more that I could have shown you some pictures of, are better and more efficiently operated now as electric railways than they were before. So the point I'm making is that we have regrettably repeated what happened on West Coast Main Line with our GW experiences recently. But every line ever electrified has, in my view and in the view of most, I think, improved because of that. So can we go to the next one, please? So let's come back to the climate crisis. That's the here and now. This is no longer theoretical, no longer something that we can choose to ignore. By 2040, we must have no diesel-only trains in operation in the UK. By 2050, we have to be net carbon zero. And all of that is legally committed by the UK government. Transport is a big part of the plan, and electrification is fundamental to the railway's response. We all know from history, the history I've just talked you through, that it is the right thing to do, and we've known that all along. We know it can be done economically. We've done it once on a few schemes. We can do it again, but we keep forgetting how to do it, and that's a bit alarming. So let's go to the next slide and talk about a couple of other things before I try and draw all this together. One of the questions frequently asked, certainly to me, is it's all very well you talking about electrification, but where does the power come from? Well, that of course is an issue. That of course is an issue for the UK economy. It's not just a railway issue. The grid has to change. It's no good us going clean and electric if actually the grid is generating power by burning fossil fuels still. So the grid has to change. Those changes have started. The capacity of the national grid in the north of England has already dropped quite a lot as a result of closure of the coal-fired power stations. There are some parts of the grid where that drop is as much as 18% in terms of capacity, but it will be addressed. The grid will need to reshape. We need to get our bid in to the grid operators and the generators so they know what electricity we will need come 2050. If we don't tell them now, they won't build it. If they don't build it, we can't have it. And the consequences of that will be quite serious. So next slide, please. So what do we need to do? Well, I'll put some words on there. Let me say what I think this tells us. ECML proves it can be done 1 year early and under budget. That was a big message in Don Heath's closure report for ECML. So I think most importantly, what I'm saying is that the senior levels in our industry must have the humility to admit that change is necessary. I yet don't see that being demonstrated fully. I think the culture and organisation change that we need to see needs to be radical, and it needs to be as radical and deep and soul-searching as happened between 1967 and 71. And we need a new culture which adopts what I've said there, a single-minded attitude which is laser-focused on cost and value for money. Next slide, please. So, the future challenges that we all face here are these. The national economy has to get to net carbon zero by 2050. Transport is a major part of that. It must play its part. We are part of the problem today, not a big part, but we must be a big part of the solution. Private cars are going to go down in number, I would guess, but they will remain in use and they'll be battery powered or perhaps hydrogen. Diesel lorries can't make that transition. Other means have to be found for lorries to move, and freight, importantly, to move that is today moved by lorries. By 2050, the whole railway has to be carbon neutral. And to be a credible and relevant part of a post-carbon national economy, the railways must hugely change their focus away from seeing freight as something that happens on the margins to something which is much more core to the railway's purpose. The Traction Decarbonisation National Strategy, which Network Rail has prepared, has identified the need for a really big increase in the amount of rail electrification. And that will remain in debate, I'm sure, with the Treasury and DfT for some time before it's signed off. But unless these challenges are addressed, many of our railways will become part of will become irrelevant, and generations to come will see it as condemned with the internal combustion engine and fossil fuels. Next slide, please. So my message then is that we have to make some changes. The railway now has a chance to move to wide-scale electrification. We need to grasp that chance. If we do grasp it enthusiastically, it will secure the future of rail as the transport infrastructure for future centuries, not just the next few decades, centuries. However, the caveat to that is that the repeat of the failures seen in history will this time have extreme consequences. Lines not at net zero will have no traction at 2050, therefore no trains, and routes will close. So like all aspects of climate change, for the railway, this is existential. On that happy note, if you have been listening, thank you.
I will look at the questions in the chat function before opening up. P. Halliwell he's actually messaged everyone and said that metrification was also applied to design and numbering north of Weaver Junction and the Midland suburban electrification. And question for you, Peter, given your talk, in what world is East-West Rail without electrification a sensible idea?
Well, as I've told them politely once or twice, it's in cuckoo land. For those unaware of what East-West Rail is, it runs across country in the area between Oxford and Cambridge. And what East-West Rail are planning to do is to discontinuously electrify the route with battery bi-mode trains, which will charge under the electrified parts of the route and run battery on the non-electrified bits. There are two acts of folly in there. One is that the battery technology, as of today, doesn't really substantiate that it's even possible to do that. Second is that the allowance of power in the traction electrified areas needs to make a proper allowance for the charging of the batteries when the trains are in that section. Otherwise, the batteries don't have the power to run off. And the third is that there are some serious questions yet unanswered about how, in periods like we just experienced over the previous 2 or 3 weeks back, when we were in freezing conditions every day, battery performance drops to about 65–70% of its full capacity. And so at the very time when you need the batteries to be heating the cabins of the train and running the traction, the batteries are at their least operable. So there are a lot of questions that the East-West rail scheme needs to answer, and it hasn't answered them. So I go back to my point, it's in cuckoo land, Pete.
Thanks. Another question from Paul Ebbett. Similarly, how can we as the PWI help to influence TransPennine to accommodate freight capacity and sufficient electrification?
Well, yeah, that's a very good point, and I am deeply involved in saying all those things within the TransPennine project world. How can the PWI influence it? My answer to that is by exercising the not inconsiderable power of lobbying. We all have the ability to have dialogue as individuals and as an organisation with influencers, politicians, senior people in the organisation, and we should use that influence in order to express views which reflect our professional standing as a professional institution. So that's a bit of a lame answer, but it's the best one I can give you. We have to just keep talking about it.
Anyone got any more questions on the mic? Sorry, another question from Peter. So how much do you think the current downer on electrification has been influenced by issues associated with clearances, the ORR, bridge parapets, etc.?
Yeah, Peter, that's correct. All of those things have brought to bear pressures on schemes throughout CP5, which were negative effects. They drove many hundreds of hours of discussion between people in meeting rooms having very erudite discussions about things. They drove investment in more work than one could possibly really justify if true business case approaches were taken to questioning why are we spending this money. The changes that I'm kind of advocating and suggesting here in culture that Network Rail particularly needs to have is, in a way, to engage with more completely and ultimately stand up to the ORR and be clear that the responsibility for the final decision about how a particular risk is dealt with are the railway's responsibility. The ORR are a regulator. I think throughout CP5, I saw examples of at various times of people in Network Rail under huge pressure, succumbing to that pressure and ceding the decision making to the ORR people. We have to stop that, and we have to take control of the destiny of the railway, to be a bit overstating it, but that's what we need to do.
Peter, Andy asks, how long do you think we have to get a delivery plan in place before it's too late to hit the 2040, 2050 targets?
Well, we've got 30 years, and if you divide up the number of single track kilometres across the 30 years and you make an even plan, we're talking about delivering a fairly spectacular 500 single track kilometres per year for about the 30-year period. That's a very crude calculation. And clearly, we're not going to mobilise to do that in the immediate term. So you can deduce from that that during the peak we'll be building more than that each year. It's a big ask. We don't have long, do we, to get started, and it would be impossible to see how we could deliver that end state in any sensible way if we're not mobilised big time mid CP7.
Thanks, Pete. Brian's been to Bulgaria in the last couple of years, and he says that he saw what he can only describe as cheap and cheerful electrification with well-spaced gantries. It was only low-speed regional, and it seemed to work. And he's asking, are UK standards too high?
Yes. Yes, they are. We have moved progressively towards a position where the pendulum has swung too far the other way. It is true that back in the 1970s, the pendulum went too far towards stretching a point too much, and we placed some of the span lengths at very long lengths. We slimmed down the equipment in places where heavier usage could better have been served by more robust equipment. That is true. But in the process of moving away from that position, we've allowed the pendulum to swing too far the other way. And I don't want to open up a debates that have gone on in the press far too much over the years, but the example of the foundations and structural steel work on Great Western is a fine example of how to lose control of common sense in places.
Stephen Long has asked, the system and componentry for 25 kVs evolved significantly through its history. What are the next steps in the system's evolution?
That's a good question. A bit of speculation then. Let's do that for a minute. What I am now feeling is the likely direction of travel here is, in terms of the overhead line mechanics, if I can call it that, then getting that pendulum that I've just talked about more balanced in the middle is the first order of business. We then move on, I think, to ask ourselves the question, how do we manage the energy flows within the system once we've built it? And the clues to some of that, and forgive the acronyms, but there is a system called IEC 61850, which is a very inspiring name, but it's more perhaps easy to understand with its colloquial name, Smart Grid. That is a protection and control system for electrical distribution, which allows the various flows of energy within the system to be better controlled and better protected. That has been implemented on Great Western, first of all as part of the electrical protection scheme, but once in place, it gives the possibility of being able to maximize the use of renewable generation with a more flexible distribution network. So I think the developments for electric traction fixed equipment are not so much about the equipment itself, but are about how we control it. The second thing that we really must actually get hold of is the way we build electrification. What that during the presentation, I talked you through and highlighted that the late BR way of doing it was the most effective and efficient that we've seen. Why was that? The answer to that question is, I believe that the principle that BR kind of developed, and you'll hear people of my age talk about this as root, rat, reseed, then electrify, was that you effectively produced the changes to the route. In those days, of course, it was changing from a steam railway to a new railway, changed the way the railway is shaped. You re-signal it, so you signal it prepared for electrification. Then when all that lot's done and the clearances are all in place, you come in and you purge the electrification. So the control of cost of build of electrification can be summarized by saying that you need to turn its build into a production process. That production process will then focus the people building it on quality, effective speed of implementation, and efficiency, rather than engineering specials at every location. And in my opinion, the priority is to address that more than anything, because if you look at the build costs of an electrification system, they are at least 3 times the material cost of the electrification. So if you can hit the efficiency of build and bring it down to its most effective, you make electrification cheaper to implement.
So Steve asked a question that sort of tags on to that, and he asks what kinds of things can be changed to make it more cost effective. You've talked about the process of delivery, but can you think of anything else, Peter?
Oh yeah, right. Okay, so I'm going to go back and sort of, having apologised for mentioning them once, I feel free to mention them again now. The structures on Great Western. Let's do a little bit of a contrast. When we built ECML, the ECML system was built using 6 standard types of structure, and of course a number of specials along the route. But the vast majority of the structures erected on East Coast Main Line were of the 6 standard types. When I came back to the UK and hello? When I came back to the UK and rejoined Great Western, I discovered to my horror that there were 400 structure types in the catalogue for Great Western. Now, think about it. If I go to a steel mill and I say, I want this section of steel, I'm going to build 11,000 structures out of it, and I want your best price for rolling that steel for me. Or I go to them and I say, I've got 400 designs here with 400 different rolling profiles, and I can't tell you exactly how many of them there are because I'm going to allocate those later on. Which one do you think would be more expensive? It's a no-brainer, isn't it? So, in fact, what I'm advocating, it's interesting, we've got John Fry on the call here somewhere. It would be interesting to hear John's views on that particularly, because I know it will be something that he will have looked at over time.
Yeah, have you got another hour and we can talk about it?
We'll do that in the pub sometime, John. Yeah. But I think it's things like that. It's actually, if you take the view that what you're trying to do is turn electrification into a production build, and you look at the production across the supply chain and the physical construction works on the railway, then you're going to tidy up the costs of each stage of the job in order to facilitate that production line. And it is signally the case that recent schemes are not doing that.
People are starting to drop off, so before we lose too many people, John, can I ask you to do the honours, please?
Yeah, of course you can, Lynn. Thank you. Peter, you and I go back many, many years, and we've worked together on a number of schemes. So I've heard you speak on many occasions, and your talks are always very informative and very entertaining, and tonight was no exception. So absolutely great talk. I love the reference to East Coast Main Line being the best scheme that BR did ever. So, thank you for that. I'd also ask the question, what would Isambard Kingdom Brunel think about the Great Western Electrification? So, that's one to mull over.
Undoubtedly, John, undoubtedly, he'd argue with me that the structures aren't big enough. But yeah, go on. Sorry, go on.
Yeah. No, and I enjoyed the sort of early references to the northeastern electrification with Sir Vincent Raven and Charles McClellan. So I wonder what it would have been like had that gone ahead in the 1920s if there hadn't been a recession. We'd probably have a completely different electrification map now. So I think your talk, as usual, was very informative, and I think the finishing note where you're saying that we need to get our costs down, otherwise the whole future of certain lines may be at risk, because we have to electrify or close them almost. That's the the inevitable result. So again, thank you very, very much, Peter, for a wonderful talk, and if we could all sort of turn off or unmute ourselves and give you a round of applause, please.
Thank you, John.
Thanks, Peter. Thanks, John.
Thank you.
Peter, I'll just